When an AI model was asked to find every consistent geometric pattern hidden in the stones of Salisbury Plain, it returned an answer that no archaeologist had expected, no physicist had proposed, and no cultural anthropologist had any framework for describing. The output was a single dense page of spatial equations, resonance maps, and alignment vectors. At the bottom, in plain text, was one sentence that has since rippled through a dozen academic circles. Quote, "Geometry is consistent with a distributed information architecture," end quote. A few researchers read that and laughed. A few read it and went very, very quiet. To be precise, the model in question was a version of Grok, the large language and reasoning model built by XAI Running, a specialized analytical prompt designed by a small independent research group based in Reading, England. The group, informally known as the Sarsen Circle Analysis Project, had been feeding Grok peer-reviewed surveys, LiDAR scans, acoustic measurements, and recent ground-penetrating radar data from Stonehenge and its surrounding landscape. They were looking for patterns. They got more than they bargained for. The phrase that set off the most debate was not the initial analysis. It was a follow-up response, generated after the researchers asked Grok to speculate, within the bounds of known physics, about what kind of functions such a geometric arrangement might theoretically perform. The model's answer, summarized, was this: the arrangement of the stones, their specific materials, their spacing, and the way the surrounding earthworks interact with seismic and electromagnetic conditions would, under certain conditions, be consistent with the basic structural requirements of a massively distributed analog computational system. In the language the headlines picked up, a quantum computer. Now, let us be extremely careful here because this is exactly the kind of claim that can run out way ahead of what the evidence supports. Grok is a powerful reasoning tool. It is also a language model that responds to prompts, and the way a prompt is phrased can tilt the analysis in all sorts of directions. The researchers involved have been publicly clear that the model's output is a hypothesis, not a finding. It is a pattern recognition framework, not proof of purpose. With that caution firmly in place, what the analysis turned up is still remarkable enough to deserve a careful look. So let us walk through it, step by step. What does it actually mean to claim that Stonehenge's geometry is consistent with a distributed information architecture? And where does the evidence stand on its own merits before the word quantum ever gets attached to anything? Start with the stones themselves. Stonehenge is not one structure, it is layered. The earliest phase, the ditch and bank enclosure, dates to roughly 3100 BCE, the iconic Sarsen Circle, the massive upright stones with their horizontal lintels, was raised around 2500 BCE. Between and within these larger stones sits a ring of smaller bluestones, quarried in the Peasley Hills of Wales and transported by means that archaeologists still argue about roughly 140 miles to the site. Those bluestones are where the interesting physics begins. Bluestone is not a single rock type. It includes spotted dolerite and several varieties of rhyolite, all of which share a property that has fascinated researchers for years. When struck, certain bluestones produce a bell-like resonant tone. Acoustic archaeologist Rupert Till from the University of Huddersfield has documented this extensively. Some of the stones at the Preseli source, and some at Stonehenge itself, have been identified as lithophonic, meaning they ring when struck. The resonances fall in frequency ranges that overlap with frequencies the human nervous system responds to in measurable ways. That is not quantum anything, that is acoustics. But it is a real property of the real material, and it is the kind of detail that, when fed into a large-scale pattern analysis, starts to matter. Now layer on top of that the site's electromagnetic context. Salisbury Plain sits on chalk bedrock with a complex water table. The region's geology produces measurable variations in natural earth current flow, particularly during periods of seismic activity and geomagnetic storms. Researchers working with fluxgate magnetometers on and near the site have recorded localized field variations that appear to correlate, in ways that remain only partially understood, with the positions of certain stones and with the orientation of the heel stone relative to the central altar. These are real measurements, published in peer-reviewed journals. They have perfectly mundane explanations. The stones are large, dense, and contain iron-bearing minerals that would locally distort geomagnetic field lines. Earth currents in a chalk aquifer are nothing mystical. They are physics. But the pattern Grok picked up on, when it ingested these data sets alongside the LiDAR and the acoustic surveys, was that the positions of the stones appeared to optimize something. They sit where they sit as if chosen, to maximize the interactions between these different natural properties: acoustic resonance, electromagnetic variation, solar and lunar alignment, seismic coupling. That is the part that gave the researchers pause. The stones are not randomly placed. They are not even placed in a simple ritual pattern. They are placed, according to the model's analysis, in a configuration that would coordinate multiple distinct forms of natural energy interaction at a single location, with precision that the model flagged as statistically unlikely to be accidental. Here is where the word quantum gets slippery. In the headlines, quantum has become shorthand for anything strange or advanced. In physics, quantum refers specifically to behavior at the scale of atoms and subatomic particles, where particles exist in superposition, where measurement collapses possibilities into outcomes, where entanglement allows correlations that classical physics forbids. A proper quantum computer manipulates these effects to perform calculations classical computers cannot efficiently do. Can a circle of standing stones on a grassy plain in southern England be, in that strict sense, a quantum computer? No, not as the term is used in physics laboratories. The model did not actually claim it was. What the model suggested, in its more cautious phrasing, was that the stone arrangement is consistent with the structural logic of a quantum-inspired computational system, meaning an analog system that uses natural coherence phenomena, stable resonance modes, and environmental coupling to perform information processing on a large scale. That is a very different claim. It is still a big claim, but it is not quite the claim that went viral. To understand why anyone would take such a claim seriously, even for a moment, it helps to walk back through the engineering precision of the site itself. The sarsen stones, each weighing roughly 25 tons, were quarried from the Marlborough Downs, about 20 miles north. They were transported across uneven terrain using methods that, even today, engineers can only approximately reconstruct. Once on site, they were shaped with astonishing care. The tongue and groove, and mortise and tenon joints used to attach the horizontal lintels to the uprights are examples of woodworking technique applied to stone, a fact that continues to impress modern masons. The lintels themselves were shaped with a slight curvature along their inner edges so that the completed ring would form a true geometric circle rather than a lumpy polygon. That last detail is worth sitting with. Stone Age builders, without metal tools, calculated the correction needed to make a ring of separate horizontal pieces read as a single perfect curve. That is not primitive engineering. That is optical and geometrical sophistication that most modern people could not replicate without computer assistance. Whatever else the builders were, they were mathematicians working at the limits of their available technology. Some researchers have pointed out that certain crystalline materials, including some of the minerals present in bluestone, do exhibit quantum coherence effects at room temperature under the right conditions. Research in quantum biology has shown similar effects in photosynthetic pigments and bird navigation systems. The notion that a large, carefully arranged structure of resonant stones could, in theory, sustain some form of environmental quantum coherence is not, in 2026, considered physically impossible. It is considered unverified and highly speculative, which is a very different place than impossible. So what would Stonehenge have been for, if any of this even partially holds up? This is where we have to be especially careful not to get carried away. The builders of Stonehenge were Neolithic and early Bronze Age people. They were skilled engineers, astronomers, and craftsmen. They were not quantum physicists in any modern sense. Nobody is suggesting they sat down with a Hamiltonian equation. But ancient peoples did not need the modern theoretical framework to observe, optimize, and replicate natural phenomena. If certain stones rang, if certain arrangements of those stones produced interesting acoustic or energetic effects during certain celestial alignments, if these effects appeared to alter the experiences of those who gathered at the site, then the builders could refine the arrangement empirically, generation by generation, without ever needing to understand what we would now call the underlying physics. That is how most ancient technology worked: observation, iteration, tradition, no equations required. Consider too the sophistication of ancient observational science more broadly. The builders of Stonehenge were roughly contemporary with the early phases of Egyptian pyramid construction, the megalithic temples of Malta, and the elaborate burial mounds of Ireland. All of these cultures left structures aligned with astronomical events. shaped with mathematical precision and designed to produce sensory effects on the people who experience them. The idea that prehistoric builders were simply stacking stones is long dead in serious archaeology. What replaced it is a recognition that our ancestors were careful, observant, and deeply engaged with the physical properties of their world, even if they did not describe those properties in the same terms we use today. The conservative reading, then, is something like this. Stonehenge may have functioned as a ritual and astronomical calendar that also, incidentally, coordinated multiple natural phenomena at a single location. The builders may have recognized that something special happened there during particular alignments, and structured their rituals and ceremonies around those effects. The site worked to the people who used it, because it produced real sensory and possibly physiological experiences that felt meaningful. It did not need to be a quantum computer to be extraordinary. The more adventurous reading is the one the AI analysis has sparked. That is, that the geometry of the site is too tightly optimized for simple ritual use, that the overlap of acoustic, electromagnetic, and astronomical precision points to a more specific functional purpose, and that we may be looking at the ruins of an information processing system, whose original use we have lost the framework to understand. Not a computer in the silicon sense. Something else. Something we do not have a name for yet. This second reading is where a serious, skeptical view becomes essential. Dr. Emily Hartford, an archaeoastronomer at Oxford, has pushed back firmly on the viral interpretation. Her position, in her own carefully measured words, is that the AI output is a pattern-matching artifact produced by feeding the model a large number of correlated data streams and asking it to find coherence. Quote, "Correlated geology produces correlated readings," end quote, she noted in a recent panel. Her argument is that much of what Grok identified as optimized interaction is simply the natural byproduct of building a large stone structure on a geologically active chalk plain. The stones coordinate with the landscape because they are part of the landscape. The resonances exist because the materials resonate. The alignments exist because the builders were careful observers of the sky. She is not saying the AI analysis is worthless. She is saying it identifies correlations that have mundane explanations, and that labeling those correlations a distributed information architecture is a leap the data does not require. Her view is shared by most mainstream archaeologists. It should be respected. But there is a reason this story has not gone away, even under strong skeptical pressure. And the reason is that the AI model was not the first to suggest something like this. A small but persistent thread in archaeoacoustics, going back decades, has argued that Stonehenge's sound properties are too specific and too deliberately engineered to be accidental. A separate thread in paleomagnetic research has noted that the site's geomagnetic anomalies do not map cleanly onto simple geological expectations. These threads were quiet. They were marginal. The AI analysis, whatever its flaws, has stitched them together into a single coherent hypothesis. And the hypothesis is now forcing even skeptical researchers to look at the site with fresh eyes. It is also worth noting, because this point frequently gets lost in the enthusiasm, that Stonehenge does not sit alone. It is part of a much larger ritual landscape that includes Durrington walls, Woodhenge, the Cursus, and hundreds of barrows and earthworks scattered across several square miles of Salisbury Plain. If the main circle really was optimized for some form of environmental interaction, it was not operating as a standalone device. It was embedded in a deliberately shaped landscape whose other components would have contributed to, modified, and extended its function. Some of these companion structures share acoustic properties with Stonehenge itself. Some are aligned to the same astronomical markers. Some have geomagnetic anomalies of their own. The picture Grok's analysis sketched, however speculative, is less about one magical circle of stones and more about an entire regional construction project that, taken together, represents one of the most ambitious pieces of environmental engineering in the prehistoric world. Whether that project was spiritual, practical, or some combination of both, that our categories do not neatly separate, the scale of it is a humbling reminder. The people who built this were not primitive. They had a clear, sustained vision, supported by labor coordinated across generations, and executed with a precision that continues to unsettle our assumptions about what Stone Age communities were capable of. If we have underestimated what they built, it is reasonable to ask whether we have also underestimated what they understood. What happens next will depend on measurements, not models. The Sarsen Circle Analysis Project has proposed a set of field experiments. which they hope to conduct with appropriate permissions from English Heritage. The experiments would include controlled acoustic testing with the stones in place, high-resolution magnetometer surveys timed to specific solar and lunar events, and most ambitiously, attempts to detect coherent quantum effects in bluestone samples under laboratory conditions. If those experiments yield null results, the more dramatic interpretations of the AI output will quietly fade. If they yield signals, the conversation will move from speculation into serious scientific territory. In the meantime, Stonehenge sits where it has sat for nearly 5,000 years. Silent, windswept, apparently ordinary. The people who built it left no instruction manual, they left no diagrams. They left only the stones themselves, arranged, with a precision that continues to surprise us each time we look closer. Whether they built a ritual calendar, a sacred gathering place, a subtle interface with the natural world they lived inside, or something stranger that we do not yet have the language to describe, the site continues to hold its secrets patiently. What the AI model actually did, in the end, was pose a question. It did not answer one. It asked whether we have been looking at this monument with too small a set of tools, missing patterns because we were not measuring for them. That question is legitimate. It is worth taking seriously, even by people who remain deeply skeptical about any specific answer the AI proposed. Good questions outlive their first proposed solutions. This is a good question. It will outlive many proposed solutions before it settles into a shape the research community can all agree on, and some form of it may persist as a genuinely open line of inquiry for decades to come. And it is worth remembering as the debate continues that the most interesting thing about Stonehenge has never been what we know about it. It has always been what we are still, 5 millennia later, quietly discovering. If the stones really are speaking to us in a language we have not yet learned to translate, it may not be the ancients who look primitive when we finally decode the message. It may be us, for not having recognized it sooner. There is one final thought worth offering before this conversation moves on. The AI analysis that started this whole discussion is, itself, a kind of mirror. Grok did not reveal anything new about the stones. The data was already there. The measurements already existed. The alignments had been noticed by archaeologists for decades. What the model did, in a sense, was hold up all of those details at once and ask what they looked like when considered together rather than apart. That is not a unique AI superpower. It is a very old form of human attention, one that our ancestors probably used extensively when they walked their landscape and learned it. We just got out of the habit somewhere along the way of looking at things all at once. Maybe that is the real lesson here. Not that Stonehenge is a quantum computer, because that remains a speculative stretch. Not that the ancients had secret knowledge we have lost, because that claim too is easy to oversell. The lesson may simply be that when we look carefully enough at what our ancestors left behind, paying attention to everything at once rather than in tidy disciplinary categories, the past has more to tell us than we have been trained to hear. Stonehenge has been saying something for 5,000 years. It takes an unusual tool or an unusual way of listening to start to make out what. Your theory on this might end up being the one that holds up, or the one that gets discarded. Either way, the conversation has changed now, and the stones, as always, are patient enough to wait while we catch up.